you to graph the inverse function and interpret it. So first off, let's find the inverse. Now remember, this is a real world application, so there's one step that we don't do here that we do with the regular x and y function. So we're going to leave, this is the, what's on the screen is the original function. So to find the inverse, we want t by itself. So we're going to subtract 600. So w minus 600 equals negative 2t. Then I'm going to divide by negative 2. So now I have t equals negative w over 2 plus 300, because negative 600 divided by negative 2 is positive 300. Now I could write it like this, negative 1/2 w plus 300. So this is the inverse function. There's no switching of t and w like we would with x and y. So this is where we stop. This is all we have to write. Okay? So the domain would be the value of w. What are the possible values for w? Okay? So it would be from 0, because that's the water, that would be the water remaining at the end of time t. And then the when they started off, the pool had 600,000 gallons of water, right? So the domain for w would be from, so I'll put D for domain, D for domain, would be from 0 to 600. And this is in thousands of gallons. Okay, so that's the other answer they want you to come up with, the domain. And then you have to graph it. So I'm just kind of sketching what you have in your book, where the horizontal axis is the water in thousands of gallons. So this is the water, in thousands of gallons. Sorry, it's so messy, but okay. And then over here is the time in hours. Okay, the time draining in hours. So if you go to, you have 100, 200, 300, 400, 500, 600. That's the maximum amount of water it has, 600,000. And then it took 20, 30, 40. So this is 20 hours, 40 hours. This is 200,000 gallons, 400,000 gallons, 600,000 gallons. So it takes 30 hours to drain the tank, or the swimming pool actually, to drain all 600. It's a straight, I know it doesn't look straight on my screen, but it should be straight. So how you read this is, if there were 600,000 gallons of water in the tank, that means that you haven't drained it at all. You've spent 0 hours draining it. But when there's 0 gallons of water in the tank, in the swimming pool, that means that the time that you've been draining it has been 30 hours. Okay? And like 200 gallons would be about 20 hours. 400 gallons would be about 10 hours. Like that. Okay? And how you interpret the inverse is, you just say, well, this inverse equation right here, this one, is gives you the time in hours that the pool has been draining as a function of the amount of water in thousands of gallons remaining in the pool. So if you know how much water is remaining in the pool, then you know how much time the pool has been draining. So that's what this equation tells you. So the last 4 problems, 3 to 6 through 6, just ask you to find the inverse. You don't have to use composition to prove that they are truly the inverse of each other, and you don't have to graph. You just have to find it algebraically, okay? So for number 3, we're following the 4 steps in our notes. So f of x becomes y, and then your next job is going to be to solve for x. So isolate the x. So we subtract 4, and then we divide by -2. So that leaves x by itself. And remember, we don't keep a negative in the denominator, so we're going to move it to the numerator. So that becomes -y plus 4 over +2. Switch the x and the y, and then change the y to inverse notation. So f inverse of x equals -x plus 4 over 2. Or if you want to separate it, you could write it as -1/2 x plus 2. Either one is fine. Okay? Alright, number 4. G of x is x over 4 minus 3. So same drill. We're going to change the g of x into y. And so now we want x by itself, so we add 3. So y plus 3 is x over 4. You want to get rid of the 4, in the denominator, so you multiply both sides by 4. And on the left side, don't forget, the whole thing gets multiplied by 4, not just the y, the whole thing. So you end up with 4y plus 12 equals x. Okay, so x is 4y plus 12. Switch the x and the y, and then change the notation to to function notation. So g inverse of x equals 4x plus 12. Okay, so number 5, h of x is 3/4 x plus 1. And so you change the h of x to y. So we subtract 1. Looks like a 7, but it's y minus 1. Okay, so you want to eliminate the 3/4, so I'm going to multiply both sides by 4/3. So by 4/3 and by 4/3. So this becomes 1 on the right side. And on the left side, you can distribute the 4. So you have, let me put the x on the left side first. So then you have 4y minus 4 all over 3. So switch the x and the y. Change the notation to inverse function notation. So h inverse of x is 4x minus 4 over 3. Or you can separate it to 4/3 x minus 4/3. Either one is fine. Okay, number 6, j of x becomes y. And so we add 6 to both sides. So y plus 6 is 5x. Divide both sides by 5. So now x is by itself. So we write x equals y plus 6 over 5. Switch the x and the y. And then change it to inverse function notation. So it's going to be j inverse of x equals, you can write it as x plus 6 over 5 as a single fraction, or you can write it as 1/5 x plus 6 over 5. Either one is fine. So there's your answer.